Dear students, in video 2, I'm going to talk on Unit 2. One of the point I have selected for today's discussion, it is a micro operations. In this lecture, I'm going to cover, at the beginning, I will discuss about the concept of micro operation. After that, we will be discussing what are the types of operations. After that, I'm going to talk to you about what are the types of micro operation individually. In this lecture, I'm going to talk three types of the micro operations: arithmetic micro operations, logic micro operations, shift micro operations, and questions are given. At the beginning, let us see what is a micro operation. So there is a concept called as the register transfer language. So here in a digital system, there is an interconnection of digital hardware module. And as all of you know, the digital system vary in size and there is a complexity and there are certain integrated circuits which increases this particular complexity by interconnecting and interacting various various components of digital components. The modules These models are constructed from such a digital components such as registers, decoders, arithmetic elements, and the control logic. There are certain various modules which are interlinked and interconnected with certain common data, and there is a control path which is used to form a digital computer system. Now, let us see what do you mean by a micro operation. But before that, let's see the digital modules are best defined by the register and the contain and the operations that are performed on data stored in them. Means, as all of you know, the digital computer comprises with various digital modules. And these digital modules are best defined by the internal components, for example, registers, and they contain the various operations which are performed on what? The data which is stored in terms of register by the various digital modules which is a part of hardware. The operations which are carried out on data which is stored in register, this is called as the micro operation. Means micro operations are done on the data which is stored in the computer register. Let us see another way of the definition of micro operation. Basically, a micro operation is an elementary operation which is performed on the information which is stored in one or more computer registers or the registers. Now, let us see in day-to-day programming what are the types of operations. In the view of computer organization and architecture, majoritarily there are two categories of the operations. One is arithmetic operations and second one is a logical operations which we have considered in today's lecture. These arithmetic operations which we do in day-to-day routine like addition, subtraction, multiplication and division. But there is one more category of the operations, that is a logical operations. So for today's session, we have considered or we have focused on four logical operation. One is a logical or whose symbol is displayed over there. Then logical and its symbol is there. Then logical exclusive or XOR we can say, and there is a NOT operation that is called as inverter, or it is also called as a complement. Now, today's our major focus to be given on what do you mean by types of micro operations. Presently, I will say micro operations as MO. There are three types of micro operations. One is arithmetic micro operation. Second group is called as a logical micro operation, and third category is called as a shift micro operation. Now, let us see the first category or first group, that is called as arithmetic microoperation. So, if you see this particular table, in one column we have displayed symbolic notations. Here R1, R2, R3. These are the computer registers named with R1, R2, R3. And there are certain operations like plus, there is another operation called as a complement, and there is a third operation called as a minus, that is called as subtraction. And arrow showing backward arrow shows the content of, or the ultimate result of this particular R1 plus R2 is ultimately it is stored in R3. So I will explain three commands later on. It is a self-explanatory. For example, R2 is equal to R2 complement. Means, first of all, the content of register R2 will be complemented, means its one's complement will be taken. One's complement is nothing but replace 1 by 0 and 0 by 1, and ultimate result will be stored in the register that is called as a R2. This is called as one example of arithmetic operation. Then suppose I want to perform the increment the contents of R1 by 1. So as all of you know, R1 has some binary content, and this particular content will be incremented by 1, and new content will be ultimately, it will be stored in R1 register. So these are the various, say, examples and operations of arithmetic micro operations like addition, subtraction, two's complement, then one's complement, increment, and decrement. Now, there is a second group called as second type, that is called as logical microoperation. Students, now let us see what is logic microoperation. Logic microoperations are specified by, by binary operations for strings of bits stored in the registers. As all of you know, that the computer register stores the data in terms of bits, and these bits are called as strings of bits, and onto which we can perform the binary operation. For example, as we have seen, logical OR, logical AND, logical XOR, and logical NOT. So we have taken one of the example of XOR. Here, the exclusive OR micro operation with the contents of two registers, that is R1 and R2, will be done. And when P is equal to 1, that time content of R1 register and content of R2 register will be performed operation called as exclusive OR. One result will be provided in terms of sum, and that result will be ultimately stored in register called as a R1. Now there are 16 logic micro operations. For example, I have discussed F2, which is equal to XY complement, means F is equal to uh, uh, F F is equal to A X or B complement. Like that, we can perform operation clearing, ANDing, transferring data to A register, transferring data to B register, then complement of B, complement of A. Then we will perform, means with the help of F14, we can do the NAND operation, and function 15, Boolean function F15, which is equal to 1, means load all ones in the given register. These are the 16 logic micro operations. Now, there is a third category called as a shift micro operation. As the name is a self-explanatory. Shift means shifting the contents of register to the direction. Direction may be the left direction or it may be the right direction by one place. Commonly, shift micro operations are used for serial transfer of data. And as it is mentioned, the contents of register can be shifted by one place to the left side or to the right side, one at a time. Now, question arises, what are the various shift micro operations? So this table shows you there are various 6 shift micro operations. One, for example, R is equal to SHLR. Now, what is the meaning of SHL? Here, R represents the computer register R, but SHL tells to the digital computer that shift the content of register R by one place to left. So here SH means shift, L stands for left. Same thing, R stands for right. Now what is CIR? R is equal to CIR capital R. Here contents of computer register R will be circularly shifted to right by one place. This is the same case with left also, CIL R, and same thing with R is equal to ASHL. Here arithmetic shift left, and same thing with R is equal to ASHR, the contents of register R. Now, dear students, in this video, we have learned what is a micro operation, what are the types of micro operation, and individually for each category, arithmetic micro operation, shift micro operation, and logic micro operation, how various 6 to 7 commands in case of arithmetic micro operations, then 16 shift micro operations, how it works, and 6 commands of 6 logic micro operations. These are discussed in brief. So these questions I am going to give you for your further study. For any help or for any kind of support, you can call me on this particular number. Thank you.